Let's learn how to use double and half angle formulas with trig functions, okay? So we have double angle formulas for sine, cosine, and tangent. So the double angle formula, in other words, the formula for the sine of twice an angle is twice the sine of one of the angle times the cosine of one of the angle. Now for cosine of twice an angle, we have three choices. We can either use this formula or that one, or that one. So any one of those three will work for you. And then finally, for tangent of twice an angle, it's 2 tangent of the angle over 1 minus tangent squared of the angle. All right, so how can we use these? Well, here's an example. Write 2 sine 3 theta cosine 3 theta as a single trig function. What does that look like? It looks like that one right there. Okay, except instead of having a 1x here, I've got a 3 theta. So instead of having a 2x here, I'm going to have a twice 3 theta. And so this is equal to the sine of twice 3 theta, which is 6 theta. Okay, now here's a little more complicated problem. We're going to find exact values of sine of 2 alpha, cosine 2 alpha, and tangent of 2 alpha, given that the cosine of 1 alpha is negative 3/5 and alpha is between 90 and 180. So that's going to put alpha in the second quadrant. Okay, so there's my angle alpha. I'm going to draw a little triangle here. And since the cosine of alpha is negative 3/5 and cosine is adjacent over hypotenuse, that means I have those two pieces of the triangle. And you may recognize that this is a Pythagorean triple, or you can use the Pythagorean theorem, but this side is going to be 4. So now we have all the pieces we need. Now, we're going to just use our formulas. So the sine of 2 alpha is 2 sine alpha cosine alpha. Okay, go to our triangle. The sine of alpha is opposite over hypotenuse, so it's going to be twice 4/5, and the cosine of alpha we were given adjacent over hypotenuse. And I worked that out. That's 2 times 4 times negative 3. Well, that's negative 24 over 5 times 5. Okay, cosine of 2 alpha. Well, we have 3 choices. So I'll just use the 2 cosine squared alpha minus 1 formula. But any one of the 3 would work. Okay, so it's going to be 2 times negative 3/5 squared minus 1, which is 2 times 9/25 minus 1, which is 18/25 minus 25/25, which is negative 7/25. Okay, now we're also supposed to find the tangent of 2 alpha, and we have a formula for that. But if I've already found the sine of 2 alpha, and I've also found the cosine of 2 alpha, well, the tangent of 2 alpha is the sine of 2 alpha over the cosine of 2 alpha. So I'm just going to use the numbers that I already calculated. So tangent of 2 alpha is sine of 2 alpha divided by cosine of 2 alpha. Flip the denominator and multiply. Negative 24/25 times negative 25 over 7. 25's cancel. Negative times a negative is a positive, and I get 24/7. To find the sine, cosine, or tangent of half of an angle, you're going to use these half angle formulas. And notice that each formula has a plus or minus in front of it, and that's because the quadrant will change when you cut an angle in half, okay? So depending on which quadrant alpha over 2 lies in, that's going to determine whether you use the plus or the minus, okay? So for example, find the exact value of cosine of 105. Well, cosine of 105 degrees is the cosine of half of 210. How does that help? Well, 210 is a point on the unit circle that hopefully you know the cosine of. Okay, so we're going to plug it into this formula right here. And 105 is in the second quadrant, so we're going to get the negative answer, okay? So the cosine of 105 is going to be negative square root of 1 plus the cosine of 210 over 2, which is the negative square root of 1 plus, now 210 is a 30-degree angle in the third quadrant, so it's negative root 3 over 2, and that's all over 2. And I'm going to multiply the top and bottom of that fraction by 2 just to clear out that little 2 right there. So that's going to give me negative square root of 2 minus root 3 all over 4, and I can take the square root of 4, so my final answer will be negative square root of 2 minus root 3 over 2. So you've got a root inside a root, but that's okay. That's just what the answer is, and that's how you do those problems.